Dear friend, this is a turbine blade. Actually, if you know two type of blade, you can find out. One is rotor vane, which is attached with rotor shaft, which is in a rotating mode, and another one is starter vane, which is in static condition, which is attached with the casing of the turbine engine. Right. You can see here one picture which is these are the blade which is attached with this type of gas turbine engine in aircraft. Right. So here you can see so many turbine blade as required uh, to give the thrust of this machine. Right. So here uh, you can find out so many processes are required to fabricate this turbine blade. Right? So as for cutting edge technology, additive manufacturing method, and also one of the thing is that how we will associate this additive manufacturing method with micro lattice structure. Okay, by combining these two type of concept, we want to develop a turbine blade. Okay, turbine blade with 1 by 8 weight reduction. Also, it is cost effective. Another one is the strength can install sustain at high temperature also. So as a whole, by our objective, we want to fabricate this type of design. Okay, turbine blade design. So this is our main aim of our company. This is Ampre Engineering Private Limited, which is associated with advanced material processing lab in metallurgical and materials engineering department in IIT Rourkela. So here, this is the prototype we made in our lab by additive manufacturing. It is a prototype polymer additive manufacturing technique. So inside it, so many designs are there. That is micro lattice structure, and as comparison to the bulk one and bulk tradition one and this micro lattice structure, when we compare the weight, we can get 1 by 8 weight reduction. This is the specialty of this micro lattice structure, which is associated with this additive manufacturing structure. Thank you.